Hi friends, if you find this video helpful, don't forget to like and subscribe. Your support means a lot. Now, let's dive into today's topic. A few years ago, in a busy machine shop, a team was rushing to deliver a batch of precision machined parts. Everything looked perfect. Dimensions were within tolerance, edges were clean, and the parts fit together beautifully during trial assembly. But when those parts reached the customer, they were rejected. Why? The surface finish wasn't up to standard. Tiny peaks and valleys on the machine surface caused excessive friction in use, and no one in the shop had actually measured the roughness. All that time, material, and effort were wasted simply because no one checked what the eye couldn't see. That kind of frustration is exactly why a surface roughness tester exists. This small but powerful device is designed to measure the microscopic texture of a surface, those fine irregularities that make the difference between a smooth-running component and one that causes wear, noise, or even failure. Instead of relying on a fingernail test or guesswork, the tester uses a highly sensitive probe that glides over the surface, recording every tiny peak and valley. Within seconds, it calculates roughness parameters like Ra or RZ and shows you the numbers you need to make an informed decision. What makes it so effective is its precision and speed. Modern testers are portable, easy to use, and often come with digital displays or even Bluetooth connectivity for quick data transfer. They help ensure parts meet strict quality standards, whether you're in automotive, aerospace, toolmaking, or general machining. By using a surface roughness tester, you're not just avoiding costly rejections, you're building confidence in your work, improving efficiency, and safeguarding the performance of every part that leaves your shop. Hello friends. If this video gave you a clearer understanding, don't forget to hit that like button and subscribe. Your support really helps us grow this learning community and keep sharing practical industrial and manufacturing insights. And if you enjoyed this simple, step-by-step explanation, be sure to check out our earlier video on the contour machine, where we explained how it works, its applications in profile measurement, and some handy tips to get the most accurate results, all in the same easy-to-follow style. You might discover something new that makes your work even more precise.